Here in this video, we are trying to learn about a concept called angle of contact, which is a part of a chapter that we are handling called surface tension. So let me try to explain to you what do you mean by angle of contact. Let's imagine a capillary tube. What do you mean by a capillary tube? It's a thin tube whose radius is very small when compared with its length. I have done a bigger tube only just for the sake of demonstration, but that's actually very thin. Imagine now that it is placed in a vessel where that vessel is filled with a liquid. As I have explained earlier, because of the surface tension, the liquid surface behaves like a stretched elastic membrane, and the surface acquires a kind of a concave shape. Sometimes it's convex too. I will discuss that in a later stage. And this liquid will rise up to a certain extent. Why it will rise, I will explain to you a little later. Let's talk about a few points now before going to talk about the rise. See this point, this point, or see this point, or see this point, or see this point. These points are called something like points of contacts. That's the point where two different materials, that is liquid and solid, are got into contact. That point is called point of contact. At any of this point of contact, we shall draw two tangents to get the angle of contact. We shall draw two tangents. How shall we draw tangents? One tangent drawn to the curved surface of the liquid. This is the curved surface now. So one tangent shall be drawn to the curved surface like this. This is a tangent to draw. My tangent may not be a perfect tangent because I am using a digital device, but this is a tangent. Another tangent drawn to the wall of this capillary tube into the liquid. So at the point of contact, another tangent drawn to the wall. Yes. These two tangents are drawn. There is an angle between these two tangents. That angle is called angle of contact itself. So how shall I define angle of contact? It is the angle drawn between two tangents point of contact. How are the two tangents, sir? One tangent along liquid surface. Other tangent, where is this other tangent? Notice that carefully. This is the other tangent. Drawn to the wall of the capillary tube. Wall of the capillary tube. Capillary tube is a thin tube whose radius is small. And that has to be drawn into the liquid. You cannot draw upward. Liquid is downward. You have to draw into the liquid. That angle is called angle of contact. So let me demonstrate the same to you at some other location. See, this is also the point of contact. At the point of contact, I shall draw two tangents. This is the liquid surface. One tangent drawn to the liquid surface this way. Another tangent drawn to the solid surface, that's a capillary tube, into the liquid. Liquid is downward. So this is also the angle of contact. I will show you at one more place just to give you a very meaning of it once again by defining. This is the point of contact. One tangent drawn to the liquid surface this way. Another tangent drawn to the wall into the container. The angle between them is the angle of contact. All these are same values itself. That's called angle of contact. So if you notice in the given diagram, if you notice it little carefully here, that angle of contact is less than 90. What do you mean by angle of contact is less than 90 means you can see the rise of the levels here. What do you mean by that angle of contact is less than 90 is this acquiring a shape of a concave. What do you mean by that? Here at the point of contact, liquid is more attached to the solid. That's because the force of attraction between the solid container and liquid, which is called adhesive force of attraction, is more stronger than the coercive force of attraction between the liquid molecules. Because of that reason, as adhesive force is more, the liquid in this capillary tube has raised. Here also it acquires the same kind of a convex shape. In fact, we can draw angle of contact here also. This is the point of contact. One tangent drawn to the liquid surface, one tangent drawn to the capillary tube into the liquid, and here is the angle of contact. Anywhere we can write the same. So one point that you have understood here is if theta is less than 90 degree, it means adhesive force is dominating. As adhesive force is dominating, liquid level rises in capillary tube. Rises in capillary tube. So you can see liquid at a higher level in the capillary tube than the normal level. This is the normal level. This is the extra level. This rise is called capillary rise. That height is called capillary height H. So capillarity is the phenomena of the rise of the liquid. Sometimes falls also. I will explain that in another example. When it is placed in a liquid, when it is immersed in a liquid, it's the angle of contact as well as the capillary rise depends on the nature of the container as well as the nature of the liquid. Now I will draw another case. So I just want to tell you an example like between pure water and pure glass. Angle of contact is equal to 0, but we never get this kind of purity. So between ordinary water, that what we drink or what we use, and normal glass, nothing like pure, angle of contact is approximately 8 degree. Between say water, pure water, and pure glass, pure silver, not glass, angle of contact is 90 degree. What do you mean by it is 90 degree? Both capillary coercive force and adhesive forces are equal, because of which there is neither rise of the level nor fall of the level. So the liquid surface also becomes flat. That's a special case. Now I will talk about another case, that is between glass and mercury. If we have taken between the glass and mercury, angle of contact is approximately close to somewhere 140 degree. It's much more than 90 degree. What happens in this case? Let me try to explain by drawing another diagram for you. I'll just scroll down the page and draw a fresh diagram. Yeah. So I'm talking about the second possible case. Let us consider a capillary tube. I'm drawing a big, thick capillary tube just only for visualization. But in real life, they are not this thick. They are very thin. Let's assume now this is all filled with mercury. This is all mercury, Hg. What happens in this case is the shape is not concave, it is rather convex shape. It will be like this. So, inside how it behaves, I will discuss it a little later, just after 2 minutes. But here it is going to acquire. Have you seen in the previous case? I just want to show you again here. See here. See here. Here it has acquired concave shape. But here it acquires a convex shape because the scenario is quite different. Because in this case, The coercive force of attraction between the mercury molecules is much stronger than the adhesive force of attraction between the mercury and glass. In between them, there is a strong bonding when compared with the outside. Whereas in the first case, that's in reverse. So if I want to draw angle of contact, again, this point I can treat it like point of contact. At the point of contact, I shall draw two tangents. One tangent drawn to the liquid surface. Liquid surface is like this, therefore the tangent has gone upward. Second is drawn to the solid surface, that's a capillary surface, into the liquid. So the angle between these two tangents theta is definitely more than 90. So angle of contact could be more than 90 or less than 90 depending on the nature of the material and the liquid. I will just draw it once again for the sake of explaining it to you. See, this is the point of contact. See carefully. One tangent is drawn to the solid liquid surface. This is the liquid surface, so this is the tangent. One tangent is drawn to the container wall into the liquid like this. This is the angle of contact, which is also more than 90, between the mercury and glass approximately 140 degree. In this case, as I told you earlier, if angle of contact is more than 90, what does it mean? Let me try to explain by concluding, right? Here, coercive force of attraction between the molecules is greater than adhesive force between the molecules of liquid and as well as the container. Because of this, there won't be a capillary rise, rather in that there will be a capillary fall. Mercury tries to prefer to stay with mercury itself rather than trying to stay with the glass. So what we can see is in this solid container, mercury will stay up to here only. Right? The remaining part will be mercury itself. But in the container, in the capillary tube, the level, see, this is the fall of the level. Do you remember? Have you seen earlier in the previous diagram? This is the rise of the capillary level. When compared with the normal liquid level, it rises. Whereas in this case, if you notice carefully, when compared with the normal level, it won't rise, rather it falls. So capillarity doesn't mean only rising, it could be a rising or even a falling also. So I can define it as the phenomena of rise or fall of a liquid level in a capillary tube when it is placed in a liquid or in a solid container is called capillarity. That can be decided basing on a term called angle of contact. Just to conclude, angle of contact is the angle drawn between two tangents at point of contact. One tangent drawn to the solid surface into the liquid, other tangent drawn to the liquid surface itself. That's it. Please revisit the video once again if you have not grasped it, and you will be getting it right. Thank you. Thank you for watching.